Hello, ninth grade extended students. Today we are going to start a new unit. It's called Sinusoidal Functions, and we are going to use sine and cosine functions to model real-world periodic functions. However, today we are just going to be looking at some functions and finding some values with our calculator. So before we get going, make sure you have your TI-84 calculator out so you have it available to you. Press pause on your video, and when you're ready to move on, press play again. So the first thing that I'd like you to do is graph this cosine function. We just finished a unit on graphing, so this should be reviewed for you. So graph this cosine function, press pause on your video. When you're ready for the answer, press play again. So here's the graph that goes along with this function. You'll notice that I figured out what the window was by taking the standard window for cosine between 0 and 2 pi. I divided both of these by b, and that became 0 to 2. And then I shifted it to the left by subtracting c, which was 1. So the endpoints of the period that I'm going to graph are between -1 and +1. I found my midpoint, which was 0. 2 more midpoints here and here. And then I've shifted my x-axis up 5 to there. And then I followed the pattern for cosine. It is a reflected cosine since my a is negative, so it's going to start 3 below this shifted x-axis down at 2. Curves back up to the x-axis, up 3 to 8, and then back down and down. So that is what my function looks like after I graph it. The next thing I want to be able to do is find a y value for a given x value. So here's my function. I want to put in a number like 3.568 as x and find out what y is. In order to do this, you really need your calculator. Your calculator needs to be in radian mode, since when we figured out b, it was based upon a period of 2 pi, and that's in radians. So let's do that first. Let me show you how to do that on your calculator. Like I'd said, you need your calculator in radian mode. So you are going to press the mode button, which is in the second row and the second column. And then you want to make sure that radian is highlighted. So to do that, you can see mine's in degree mode right now. I'm going to tab down to radian and press enter so that now radian is highlighted. Now it's in radian mode. And let's quit out of here. So second, and then notice right above the mode button, it says quit. So I press that. So now I'm back on my home screen. And I would like to find out what f of 3.568 is. So I'm going to put in my calculator. Notice -3. I have to use this negative down here, not the minus sign. It would give me an error. Negative cosine of pi. To find pi, you press second and the caret up symbol, and then another set of parentheses, and it would be 3.568 plus 1. We're just substituting in for x. I have to put 2 sets of parentheses here. Ooh, and I forgot the 3. Let's see, let's tab back here. It was -3 cosine. So let's see, I'm going to go to the right. I have to insert that. So second, insert. I put the 3 there. Okay. And now get that to the end. And then I have to add 5. So f of 3.568 is 5.636 rounded. Now let's take that function and set it equal to y and solve for x in terms of y. So I'm going to take my function. I'm going to let y equal -3 cosine of pi x plus 1 plus 5. Okay, So let's solve for x in terms of y. So we're going to unwind what's going on here. So we're first going to solve for cosine of pi times the quantity x plus 1. Remember, it's implied that there are parentheses here. So I'm going to subtract 5 from both sides and then divide by negative 3. So y minus 5 equals negative 3 cosine of pi x plus 1. Divide by negative 3. Y minus 5 over negative 3 equals cosine of pi x plus 1. Now, the way you undo a cosine is you take the inverse cosine of both sides. So I'll have inverse cosine of y minus 5 over negative 3 equals pi times the quantity x plus 1. So now I am going to divide by pi, or multiply by 1 over pi. Oops, let's see, I don't like the way that was written. I want it to be more clear. That's negative 3. That's equal to x plus 1. And then I'd subtract 1 from both sides. 1 over pi inverse cosine of y minus 5 over negative 3 minus 1 equals x. So in case you didn't realize what we just did, we found the inverse function for our function f. So let's write it that way. So inverse of f is equal to, remember, an inverse happens by switching x's and y's and solving for y. In this case, I solved for x, and now I'm going to switch x and y's. Instead of writing y here, I'm going to write x. So that would be 1 over pi inverse cosine of x minus 5 over negative 3 minus 1. This is my inverse function. This equation, I set my function equal to 2.56. In my calculator, I put the 2.56. I have to subtract 5 from both sides. So subtract 5 from both sides, and you'll notice I need to write down every step as I go, because if I make a mistake, I want to know where it is. So now I should have minus 3 cosine of pi times the quantity x plus 1 equals negative 2.44. Solving for cosine, I divide by negative 3. So divide, you can't use this minus, negative 3. Once that happens, I get cosine of pi times the quantity x plus 1 equals 0.813 repeating. Now, to get the x out of the cosine, how do I undo a cosine? I take inverse cosine. So to do that, I would press second cosine and then second of the answer I just got. Now I should have pi times the quantity x plus 1 is equal to 0.6209. And now I want to divide both sides by pi. So when I do that, I divide by pi. Notice the pi is right above the caret symbol. Second caret symbol, I divide that by pi. And now I have x plus 1 equals 0.1977 rounded. Notice, I let this be my full extended decimal, even though I just wrote 0.6209 on there. I want to minimize rounding error. Now I'm going to subtract 1 from both sides, so minus 1. So the x value for which my y is 2.56 will be negative 0.8023. That's one of the x values that will give me that y. This equation, I set my function equal to 2.56. In my calculator, I put the 2.56. I have to subtract 5 from both sides. So subtract 5 from both sides, and you'll notice I need to write down every step as I go, because if I make a mistake, I want to know where it is. So now I should have minus 3 cosine of pi times the quantity x plus 1 equals negative 2.44. Solving for cosine, I divide by negative 3. So divide, you can't use this minus, negative 3. Once that happens, I get cosine of pi times the quantity x plus 1 equals 0.813, repeating. Now, to get the x out of the cosine, how do I undo a cosine? I take inverse cosine. So to do that, I would press second cosine and then second of the answer I just got. Now I should have pi times the quantity x plus 1 is equal to 0.6209. And now I want to divide both sides by pi. So when I do that, I divide by pi. Notice the pi is right above the caret symbol. Second caret symbol, I divide that by pi. And now I have x plus 1 equals 0.1977 rounded. Notice, I let this be my full extended decimal, even though I just wrote 0.6209 on there. I want to minimize rounding error. Now I'm going to subtract 1 from both sides, so minus 1. So the x value for which my y is 2.56 will be negative 0.8023. That's one of the x values that will give me that y. Now, as I said before, if I put in a value into my function, negative 0.8023, if I put that in for x here, I'm going to get out 2.56. But this says find the 3 smallest positive x values, and you'll notice that this is negative, so that is not one of them. But I can locate it on my curve and use the symmetry of my curve to find the other values. So let's see here. I want my function, my y value, to be 2.56. And you'll see here the lowest it hits is 2. And this negative 0.8023 is between negative 0.5 and negative 1. It's somewhere in here, like, I don't know, let's call it there. Now, I'm going to use the symmetry of my curve to find other values. You'll notice every relative maximum and relative minimum will give me a point where if I draw a vertical line through it is a line of symmetry. So looking at this, I can see that this would be a line of reflective symmetry. So I can find another value on the other side here where my y value will be 2.56. And I do that by finding the distance that point is from that vertical line of symmetry. So using my calculator, I would take 0 minus a negative 0.8023 to find this distance here. So that distance is 0.8023. Now, I should have another value, because again, that is a line of reflective symmetry, that gives me my same y at 0.8023. So that is one x value right there. Oops. Now, it's the first x value, but there's many more. In this curve, I can find the other ones by just extending it and remembering that this is a line of reflective symmetry. So, to find the point that's on this side, I would find the distance. This is from 1, add it to 1, and I will get the next value. And that distance is 0.1977 away from 1. So when I add that to 1, I get my next value, which would be 1.1977. Now, once I have a point on either side of a minimum or maximum, I can just simply add the period to each of these, and it would reproduce every single point that is going to give me a y value of 2.56. So I have 2 right now. Those values are x equals 0.8023 and 1.1977. Now, anytime I add a period to either of those, I'm going to get another solution to my equation where I set this function equal to 2.56. So I'm going to take these and add my period. And now remember, the period is 2 pi over b. And b was pi, so my period is 2. So I can get the next non-negative number by adding that period, 2.8023. And it asked for the first 3 smallest positive x values. I could find another one, but that's going to be larger. And I really just need 3. So these are my answers. All right, I'd like you to try doing a similar process for this problem. Graph it and find the 3 largest negative values this time of x, such that f of x is equal to negative 3.42. Press pause on your video, and when you're ready for the answer, press play again. Okay, here's the answer. So you'll notice that I first graphed my reflected sign. I graphed it right here. So I found my window, which was negative 1 to 3. You can see it was 0 to 2 pi. I divided by b. I subtracted c, which was 1, and I graphed between negative 1 and 3. And I found my critical values, and I drew sine. I shifted my x-axis down 5. I remembered the amplitude of the sine function's 2, but it's reflected, so it goes down 2 first, and then back up and around. The next thing I did was I set my function here equal to negative 3.42. You can see that I show all of my work from every single time I do something to my function. So looking at this, I added 5 to both sides. Then I divided by negative 2. I'm solving for sine. Then to get this out of my function, to undo sine, I had to do inverse sine of both sides. I multiplied by 2 over pi. That got me here. And then I subtracted 1. So this is one of the negative values that will give me a function value of negative 3.42. Now I've got to use that in the symmetry of my graph to find my other points that will produce that same y value. Now you'll notice negative 1.58 is to the left of here. So I extended my curve to the left, and I knew that I was going to have another relative max, a period back. My period's 4. So if I subtract 4 from 2, that's where my next one is. Here is my negative 1.58. That's going to give me a y value of negative 3.42. It's going to be in there. And then I use the symmetry of my graph through this relative maximum. I noticed that the negative 1.58 was 0.42 away from this relative max. Then I subtracted that from 2 and found this other value on the other side, negative 2.42. So far I have these 2 values. And then to find one more negative, what I did was I subtracted the period from this to get the other one. If I wanted a 4th value, I would subtract the period from this as well. Once you get two values on either side of a relative min or max, you can simply add or subtract to find all the other values that would produce the same y. Here's another problem. I'm giving you the graph this time, and I want you to write the equation for that graph in terms of a non-reflected sine function. We just finished graphing. You should be able to do this. It's review. Press pause on your video, and when you're ready for the answer, press play again. So here's my answer. Notice the period of my function is 8. It starts at 2, and it'll start repeating at 10. That's 8 away. So I first found my b value. I took 2 pi, and I divided by 8. That simplifies to pi over 4. Remember, I'm writing it as a non-reflected sine function. Now, looking at this, I need to know the amplitude. The amplitude is the distance between this shifted x-axis and the top and the bottom. How did I find this value here, this shifted x-axis? I averaged these two. 6 plus a negative 2 is 4, divided by 2 is 2. Then I can see that the amplitude is 4. Then I know that d, again, is 2. It was the average of these two values. And the next thing I have to do is I have to find the shift. So it's a non-reflected sine function. So I'm looking for a value that is on that shifted x-axis where it's going to start rising above. So that is 8. When it's shifted to the right, it's a subtraction. So here is my function. The next thing I want to do is I'd like to use this equation to find the 3 smallest positive values of x, such that g of x is 2.56. So set this equal to 2.56, solve for x, find the 3 smallest positive values. Press pause on your video. When you're ready for the answer, press play again. So here's my answer. So I set my function equal to 2.56. I solved for sine. I subtracted 2. I divided by 4, making me 0.14. To undo a sine, I have to do inverse sine of both sides. So now I have 0.1405 is equal to pi over 4 times the quantity x minus 8. Multiply both sides by 4 over pi, or you can think of that as dividing by pi over 4. So I get 0.1788. That's equal to x minus 8. And then finally, I'm going to add 8 to both sides. And I find my x value is 8.18. This x value will produce a y value that's 2.56. Looking up at my graph, I can see that that makes sense. 8.18 is to the right of this. It's above this shifted x-axis. So I know this y value is going to be higher than 2. Thank goodness, because that's what I want it to be. And now what I have to do is use this line of reflective symmetry to find a point on the other side of this minimum. So 8.18 is 2.17 away from 6. Interesting, that must be a rounding thing. Then I just subtract this distance from 6, and I find 3.82. So now I have 2 values on either side of this relative minimum. To find my additional values, I can add or subtract the period. So if I look at this 8.18, you should notice my period's 8. I can subtract 8 from this and still get a positive value. So here are the first 3 non-negative positive values that will produce a y value of 2.56. Your homework is similar to this. Take a look at it. We will go over it in class next time we meet. Have a great day.